All right, so we are asked to figure out if this data is linear, and well, actually, we're kind of assuming it is because it says explain why. And then to find the equation. So if we look at what our x's are doing, we are going to be increasing by 2, by 2, by 2, then by 4, 2 and 4. And if we check what our y's are doing, it's going to be going down by 3, down by 3, down by 3, then down by 6, then down by 3, then down by 6. One thing, note that I saw a couple people do on the quiz, I assume. Make sure you're being very careful with the sign of the change. So if it's a decrease, you need it to be negative, because then if you don't keep track of the negative, then you will have an incorrect sign on your slope. So we have our change in y over change in x is -3 over 2, and then we're comparing that to -6 over 4. That's the only two situations we have here, but the -6 over 4 would reduce to -3/2, so that's good. So this is linear because the slope is constant. And we'll have a constant slope of -3/2. So if we want to find the equation at this point, since we have the slope, this is when we would have to find our y-intercept. Now here, technically, we're given the y-intercept, so if you just want to pull it off, you can. I'm going to do the other way as well, and say, for instance, we weren't actually given that point, but remember, if you were given a point where the x is 0, that is going to tell you your y-intercept. So you could just use that as your b-value. But say you didn't, maybe you didn't see it, or you just didn't care, whatever, and you're going to do it the regular way. So you're going to pick a point. I'm going to choose the -614. You're going to plug it into the y equals mx plus b format, but we don't know what b is. And then this, if I remember correctly, because my arithmetic's bad, I think that it is 9. Yes. So 14 equals 9 plus b. Subtract 9 from both sides. You'll get that b is 5, which is good because that's what it should be. So then our equation is going to be -3/2 x plus 5. So again, you technically already knew the y-intercept, so you could just write the answer without doing that extra work. But if you didn't recognize it, or you just want to triple check or something like that, you could do it the other way. And it doesn't matter which point you use. You could have used the -411, -2.8, 4, -1, so on and so forth. You still should have gotten +5 as your y-intercept. Questions, concerns about that before we continue on with our notes that we've got here? Also, I will give you one last reminder. I usually won't be reminding you this much, but it's the first one. So you've got your homework due tonight. So 11:59 p.m. is when your first homework's due. The second one should be appearing today. So there's, one day where there's a little bit of overlap, but you don't have to start the second one right away. And also to clarify, the orientation is highly suggested that you do it. Maz, sorry, my cat. And so the orientation is optional, but it's suggested. But the only thing that's required is the homework one. Where do you find it? It's on WebWork. So here's the link in chat. But then on Blackboard, if you're in the course content, there's also the WebWork access. And if you pop into that, and then you can click the one that says WebWork, it also sends you over there. Again, your username should be your username that you pretty much use for everything, essentially your email without the @ blah, 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 blah. Make sure your username is lowercase. If you put capitals in the username, WebWork gets angry. I've never seen something get angry about be case sensitive as a username, but apparently it is. And then your password, unless you've changed it, remembers your student ID. If for some reason you can't get in, you forget the password you've changed it to, if you've changed it, I can always reset your password. So if you have trouble getting in at any point, just shoot me an email and I will set you up with that. One last tiny thing, I think I sent it in an email. I think with WebWork, every once in a while you might hit submit answer and it might say, you know, authentication error or something. It'll give you a little error. Wait about 1 second before trying again, and then usually it'll accept it right through on the second one. I did it myself. I got through most of it pretty well without any issues, but every once in a while it would pop up with that error and I would just have to wait a second and then it would accept it. Homework is, yeah, pretty much going to be due every Monday. That's why I'm not going to keep reminding you. It's pretty much a Monday to Monday kind of deal. The only time I'll remind you till, you know, my face is blue is if that ever changes. I doubt it will. Although there's one day, I think President's Day is a Monday and a holiday, and there's not supposed to be anything due on Monday. So on President's Day, it'll be due on Tuesday. But I will remind you about that multiple times. But the large majority of the time, Monday to Monday, I won't be reminding you, just Monday. Okay. Any more questions about anything before we start? All right. So a reminder, we started this average rate of change notes last time. So remember, the average rate of change is essentially a slope. It's just used in a broader context. So we can talk about average rate of change even when we don't have a linear function, because it's essentially creating a line between 2 points. And we got through one of these. And now let's do the rest of them. So here we were finding the average rate of change using the function 1/16 x to the 4th minus x squared. And so we walked through the first one last time. So essentially we plugged in 0, we plugged in -2. I didn't have really a lot of space to write that fully out, but kind of off to the side, just a reminder of how that would look if you did plug it in to that function. So anyway, looking at the second one, g of -2 minus g of 4, if we plug in -2 to the function, we found that last time. We plugged in -2 for the first one. So we would get -3. And then if we plug in -4 to the function, we're actually going to get 0. And also, since we have the graph, you can kind of triple check that I'm not lying to you. The graph at -4 is at 0. So plugging in -4 would give us 0 as well. And then -2 minus -4 would give us +2. So we'd end up with -3/2 as our average rate of change. And if I wanted to phrase this as an average rate of change, this is the average rate of change between x equals -2 and x equals -4. And it doesn't matter which way you write that. You could write average rate of change between x equals -4 and x equals -2. Just like slope, it doesn't matter which one goes first as long as you're consistent. If the -2 y value, the y value associated with -2 goes on top first, then you need the -2 in the bottom first. But just like with slope, the actual format, which one comes first, doesn't quite matter. So the other thing we were asked to do, this is part B of that question, is to then draw the line between those 2 points. So if we're at -2 and then -4, we draw the line between those, and I'll try to make this one dotted. So I know some people might be colorblind and maybe can't see the difference, and that's why I kind of boxed this in a dotted fashion. And so essentially that means that the slope of this is -3/2. And then if we look at our part 3, we've got g of 0 minus g of -4 over 0 minus -4. So g of 0, if we plug in 0 to our 1/16 x to the 4th minus x squared, we're going to get 0. Then if we plug in -4, we're also going to get 0. That's going to be all over +4. That, of course, reduces to 0. So this will be the average rate of change, which again, I usually always abbreviate because I'm lazy, between x equals 0 and x equals -4. Now, I don't know another way to break up a line. I already used dotted, so I don't know. I don't want to make it wavy because then it's not a line. So -4 to 0, I'll just unfortunately have to use a straight line again, not dotted or anything like that. Really long dotted lines, that could also work, or maybe like little baby ones. Or yeah, you know what? Let's do that. Let's make it. Wee. That's not where I want to draw. Wee. And then they're longer than the other one was. I don't know. I guess. Who knows? Anyway. So the fact that it turns out to be a horizontal line makes sense because it has the slope of 0. So there we go. Questions, concerns on that question before we go to the next one? And I'll also hold on a couple seconds in case people are still writing something down. Oh, I guess I pointed out the rest of them, so this would have a slope of 0. It's getting a little cluttered now, but all right. So our next one, compute the average rate of change for a bunch of different values. So let me break this up so I don't run out of space. So our function now is 2x squared, and we're going to go over the following intervals, 0 to 1. So here, if I wanted to write it out in its full, average rate of change format, g of 0 minus g of 1 all over 0 minus 1. Now, again, you can put the 1 first, and usually I would, but since it's written out 0 is less than or equal to 1, then I just wrote it in that format. But again, it doesn't matter which way, whatever works. So we would have 2 times 0 squared. I have a little more space this time, so I'll actually write out it plugged into the function. One thing I want to say really quick about this is be very careful with potentially needing more parentheses. And also, I'm probably just going to put everything in brackets just to be super careful. You wouldn't need them here. But if I scroll back up to this one really quick, and let me do it down here, and then I'm going to erase it. But say I wanted to calculate the g of 0 minus g of negative 2 over 0 minus negative 2. If I were to plug that into the function, I would have 1/16, 0 to the 4th minus 0 squared. And I'm going to write it out in the wrong way. And then I would plug in negative 2 to the 4th minus negative 2 squared all over 0 minus negative 2. If I left it like this and I punched it into a calculator, I would actually get the wrong answer because it's not distributing this negative to both of these terms like it needs to. So if it were something like this, I would actually need an extra set of parentheses or brackets if you prefer. I wrote brackets in the other thing I just wrote. To make sure that it actually reads correctly if you were to punch it into a calculator, unless you were to distribute that negative yourself and turn this into a positive sign, that would work. I suggest just using extra parentheses. So, and you could put parentheses around this part too, if that makes you feel better. They aren't necessary in the front because there's no negative to distribute, but be really careful if you have a back term that has more than one piece to it, you would need a set of parentheses around it, or just be really super careful and make sure to distribute that negative. Okay. I'll leave that up for like 5 seconds and then I'm going to erase it because it's, no, I'll leave it there. Actually, there's nothing else that was going to go there, so I'll just leave it there. So in this case, we didn't really need those brackets that I put there because there's nothing to distribute a negative to that's not already getting the negative. But just to be careful, if it helps you to do it all the time, you can do so. So we'll get whoops. In my notes, I have it the other way. So 0 minus 2 over negative 1. Negative 2 divided by negative 1 is, of course, positive 2. And then if we're going from negative 1 to 1, we'd have g of, I'm going to put the larger x value first this time. Again, does not matter which way you do it, as long as you're consistent. So we have 2 times 1 squared minus 2 times negative 1 squared all over 1 minus negative 1. So again, here you could put the brackets around everything. They're not needed here because we only have the one term. So we would end up with 2 minus 2 over 2. Running out of space a little bit there. Should have wrote a little smaller. So we'd end up with 0. because the 2 over 2, sorry, 2 minus 2 would of course give us 0. One moment. All right, and then -4 to +2. I'm just going to go back and forth, and now I'm going to put it in the order that it's listed. Again, doesn't matter. So we'd have 2 times -4 all squared minus 2. Oh no, 2e. Shoved it in there. And so this would give us 32 minus 8 all over 6. -6. Which would reduce to -4. So the average rate of change between -4 and 2 is -4. Now on this one, these next two, we don't have any numbers, we just have letters. So it's going to be left in a more generic format, which is fine. So we'd have g of a minus g of b all over a minus b. So really the way we would leave it is essentially 2a squared minus 2b squared all over a minus b. There's nothing else to reduce there. Now this last one is interesting because it's going to come up, its format, I should say, is going to come up in a, the word just left my brain, in a definition in a couple sections. So on this one, I'm going to be very particular. I'm going to put the a plus h one first, just because that's the way it'll show up in the format later in our lives. So here we'd have 2a plus h all squared minus 2a squared all over. Now notice in the denominator how we have a plus h and then minus a. So the a's would actually cancel each other out and you would just get h. Now you could do a bit more simplification on that. If you expanded out the numerator, the 2a squareds would actually cancel out, and we could actually do a bit more simplification here. But I'm going to stop because it's not worth it at this point. Not necessary at this point, I should say. Okay. Questions, concerns on any of those? Okay, now this problem's going to feel a bit different. And it's probably one that I would usually ask you to do if we were doing this in class, but I'll just go through it with us. These notes are very much laid out, preferable to in-person classes, but we're getting through it. So the amount that Mary drives changes from week to week, so the amount that she spends on gas also changes. However, she calculated that over the last year, she spent $1,450 on gas. She needs to own a hybrid. They're great. On average, how much does she spend each week on gas? So if you think about this, it doesn't really sound like an average rate of change question, but it kind of is, because if you think about the starting value being like 0, 0, and the ending value being after 52 weeks, she spent 1,450. We're essentially taking the 1,450 and dividing it by the 52 weeks that are in a year. So this is, of course, dollars in 52 weeks. So she would be spending approximately, $27.88 per week on gas. Which just sounds like a lot to me, but maybe I just don't drive a lot. And then if nothing major changes, how much should Mary budget for the next 3 weeks? Well, we're going off of this kind of average to get an idea. So if we're just taking this average and she's going over 3 weeks, we would just have to multiply by 3. So she would want about $84. 83.64, but about $84. So I know that feels a little different. It doesn't really sound necessarily like an average rate of change, but it, in its essence, it kind of actually is. All right. Speedometer in Jacob's car is broken. If there were any questions on it, let me know and I'll go back. Oh, it's lagging. Is my laptop angry? The internet didn't pop out. Oh, there it goes. Let me unshare and reshare just to make sure that doesn't. If I'm ever like just chugging along and it's super duper lagging for you, yell at me in chat. because I have it up on 2 screens and sometimes I notice the lag, but then other times mine isn't lagging, but yours is lagging and so anyway. So the speedometer in Jacob's car is broken. On the way to the store, he was able to measure the distance from his house once per minute. Drive a minute, stop and measure. The table below shows these measurements. So T is going to be in minutes and the distance is going to be in feet. I'm going to name this F of T just because of the format, the notation I'm going to want to use. I'm going to want to write it in function notation. So I'm going to name that F of T because we weren't given a name for it. So what was Jacob's average velocity between the start of the trip and 3 minutes in? So one thing I want to say really quick before we go through with this problem is the words average velocity. This is just, that's a little too large of an arrow. So average velocity is just an average rate of change for distance. So it's nothing like super duper new or anything like that. Technically, we hadn't seen the words average velocity yet, but it's just telling us to take an average rate of change. It's just in this very specific context that's usually stated as average velocity instead of average rate of change. So start of the trip would be T equals 0, and 3 minutes in would be T equals 3. So we essentially want our F of 3 minus F of 0 all over 3 minus 0. Excuse me. So here, there's nothing to plug into. There's no function. So what we're going to do is we're just going to pull the values off the table. So F of 3 is giving us a distance of 3,300. Whoops. There we go. And then 0 has a distance of 0, all divided by 3. So that will mean that his average velocity during those first 3 minutes is just going to be 1,100 feet per minute. And then what about between 2 and 3? So now we're doing F of 3 minus F of 2, all over 3 minus 2. So 3,300 minus 2,600 over 1. You can, of course, write it as 3 minus 2 and then reduce it later, but so that would reduce to 700 over 1, so 700 feet per minute. Let me make sure to clarify where I'm getting that feet per minute from. So remember, this is kind of a slope. So if a slope is a change in y over change in x, the units are the y units over the x units, or whatever variables we're talking about. You can also just kind of try to keep track. So like the numerator has these 3,300 in the 0, which came from the feet. And then the 3 minus 0 came from the t row, so minutes, so feet per minute. So you can also just kind of keep track of where the values were coming from and what units they had to set up the units of the average rate of change correctly. Okay. Questions about those two parts before we move on to the next part? Same question, just different part. All right, so we're going to want to, excuse me, we're going to want to graph these next. So the setup I'm going to use is I'm going to make all of the, get out of my highlighter here. I'm going to make the T lines go up by 1. And I'm going to make these vertical lines go up by 1,000. Now that's going to mean we're going to go slightly off of the graph at the very end, but I think it's better than trying to smush it down anymore because because we really don't have to go that much higher than the graph. It's just that we need to go a little bit past 7,000. So over here we'll get a little bit above the graph, but it'll be all right. So by 1s on the horizontal and by 1,000s on the y's. And I'm going to try to squeeze the table back in here real quick, and then I'll zoom back in when we get to it. So we've got 0, 0, so that's just our origin. We've got 1, 2,200, so just above the 2,000 line. 26,000, so about halfway, a little bit more than halfway. Let me move that up a little bit. Or not. Good enough. Then we've got 3,300, so a little bit above the 3,000 line. And then suddenly we jump to 6,200. So 4 gives us 6,200, so just above the 6,000 line. 5, 7,000. And then here we've got 7,273,000, so that would be just above essentially the top of this graph. So we're going off a little bit, but it'll be all right. Let me zoom back in now that we've looked at our table and plotted all the points. Zoom back out a little bit. There we go. So if I were to try to draw what I think is happening, so I can't know exactly how it's changing in those kind of spaces between these points, but based off of where the points lie, I can at least get a general idea of what's probably happening there. And now what we're asked, let me pause a second in case people are still drawing. What we're then asked is we're then asked to pick the two data points where we think the average velocity is the largest and then the smallest. And so if we start with, so average velocity largest. So when you're thinking about this, you do kind of want to think about the fact that this is a slope. So you want to think about this as the slope being largest. And being largest in terms of slope would mean it's just, oh my gosh. You're looking for like the steepest slope between 2 points. So if we just take a good educated guess here, it probably looks like the steepest slope between 2 points is probably going to be between 3 and 4, because like that's a pretty large jump. There's a pretty decent jump between 0 and 1 as well, but it definitely looks like a bit bigger of a jump between 3 and 4. So we're going to say that the average velocity looks like it's going to be largest between 3 and 4, and it actually is largest there. It's a larger jump from there to there than from there to there. So it is a larger jump, so it will have the steepest slope. And now with the way I've drawn this smallest might be a bit harder to see because we have two really good contenders here as well, between 6 and 7, and then between 1 and 2. Now, technically, 1 and 2 are spaced out a bit more than 6 and 7. And the other way that you can triple check yourself on that is to go back to the table. So look between 1 and 2. The difference between 1 and 2 is 400, whereas the difference between 6 and 7 is only 100. 100 is obviously less than 400. So that would mean that the slope between 6 and 7 has to be less than the slope between 1 and 2, because they're both just a difference of one point away. So here, even though they both look pretty close, because I can't draw them perfectly, the smallest average velocity would be between t equals 6 and t equals 7. And then the last piece of this question is then asking us to actually find that largest and smallest average velocity. So if we look at the largest, that was between our t equals 3 and t equals 4. So we'd have our f of 4 minus f of 3 all over 4 minus 3. So if we go back to the table, I'm not going to scroll back up, but if we go back to the table and grab those values, it would give us 6,200 minus 3,300 all over 1, which reduces to 2,900 over 1. I go through a lot of these calculations very quickly because I assume if you punch it into a calculator, you'd be good. But if there's ever a time where, whoop, that's not what it is. That's I'm looking at the wrong thing. 2,900. If I'm ever going through something too quick and you're like, where did that come from? Just stop me. So the largest average velocity would be 2,900 feet per minute. And then the smallest, we kind of already talked about this already because I looked at the values, but that would be between our 7 and our 6, which had a difference of 100. So hopefully this comes out to 100, which it will, because otherwise I lied to you. So the smallest average velocity would be 100 feet per minute. That F looks really silly. There we go. So average velocity is an average rate of change, is a slope. Lots of different ways to say the exact same thing. questions, concerns about that before we move on to a slightly different topic? Questions about average rate of change in general or anything like that? I'll wait a couple seconds also in case people are still writing stuff down. And then we'll move on to our slightly bit different topic. Alrighty. Okay. Then our next definition is for when a quantity P changes from P naught to P sub 1. So I read this as P naught, and I think it's an A and not an O. I actually don't know. If you say P sub 0, it's fine. It's just more often referred to as P naught. So if you ever hear me say P naught or T naught or X naught or whatever, I mean the one with the 0 on it. So changes from P naught to P1, we defined the relative change to be the following. So we take P1 minus P naught over P naught. Or the way I like to think of it is I actually like to tell myself end minus beginning over beginning. So a lot of times people will get it mixed up, especially if they're thinking about the P1 and the P naught by themselves. So I like to phrase it as end minus beginning over beginning. Be very careful if you need to keep track of the beginning value and the end value. A lot of people will accidentally put the end value in the denominator, and so make sure end minus beginning over beginning. And essentially what this does, it's a way to talk about how a function is changing over a specific period. Essentially, it's a way to say kind of a percent change, because I'll write it down in a second. We usually write these as percentages. So it's essentially telling us like the percent change over a certain period. This is usually unitless. So your answer usually doesn't have any units. And we usually write the answer as a percent. So we'll get an answer in terms of a decimal, and then we'll usually rewrite it as a percent. So, got some really silly questions coming up. So, if January 2017, YouTuber X has 1.5 million YouTube subscribers, and today the channel has 2 million YouTube subscribers, what is the relative change of the number of YouTube subscribers of YouTuber X between the first two data points? Between these two data points, not first two. So, just to be super clear, why does that look like that? The beginning value is we're starting at the 1.5 million. And the ending value is the 2 million. Now, just to clarify and give a little extra note, if one of these was like billion, or if it started in the thousands and then ended in millions, we would need to be really careful about converting them to the same amount. Like if we were given one of them in billions, we would have to convert it to millions. If one of them was given in thousands, we would have to convert that to millions, or we would have to convert the other one down to thousands. You know, so you want to make sure that your units match if you're just going to start subtracting things. Since they're both million here, we don't have to like write them out as actually 2 million with a bunch of zeros. We can just use 2 and 1.5. But I do want to be very clear that you should be triple checking before you start just subtracting things or writing down answers, because if the units are different, then things are getting a bit wonky. Anyway, relative change, end minus beginning. So 2 minus 1.5 divided by the beginning value of 1.5. So this will give us 0.5 over 1.5, which will reduce to 0.3 repeating, as long as my notes aren't lying to me. Every once in a while, I do something stupid when I write my notes down and the arithmetic's wrong, but you know, that's right. So 0.3 repeating. So for the fact that we're going to change it over to a decimal, I'm just going to take 4 decimal places and then chop it off. If you don't remember how to change a decimal to a percent, you take that decimal point and you plop it 2 spaces over to the right. So this will become 33.33%. And then usually with these, you usually also want to denote whether it's an increase or a decrease. And that just depends on, is it a positive number or a negative number? So since this is a positive decimal, this would be an increase. If it was a negative number, you essentially take off the negative from the front and then just write decreases. You would never write like negative 5% decrease, because technically, I guess that would be an increase. Anyway, so this is essentially saying that over, well, I guess if we're taking it today to be today, over those 4 years, there was a 33% increase in the subscriber count. If there's no questions about that one, we'll do this next one. I'll try to leave some of that in there. There we go. I'll scroll down a little bit more in a second. So our next problem: during the first week of the semester at Evil Public School, the enrollment in Nina's business calc changed from 130 to 162, while the enrollment of Cortex's business calc dropped from 18 to 8. What I wouldn't give to have a class of 8. Anyway, which class had the higher relative change in magnitude? So remember, when we're talking about magnitude, we don't care about the sign, we just care about the numeric value. And maybe I should be careful about saying, anyway, you'll see what I mean in a second. So then I'm going to leave space for the final answer down there. So let's do the relative changes here. So we've got Nina's versus Cortex's. So Nina's started at 130 and ended at 162. So if we do our end minus begin, it'll be the 162 minus 130 over 130. So that'll give us 32 over 130. That's a 1. That looks like a 7. Which reduces to 0.246. We won't need it, but just to really knock that home, that'll be 24.6%. Actually, no, I will write them as a percent. And this would be an increase. That part we don't really need, but. And then Cortex's started at 18 and ended at 8. So end minus beginning would give us 8 minus 18. That's the other thing. I find a lot of people will accidentally always put the larger value first. No, no. It really depends on where you started and where you ended. So we started at 18, dropped down to 8. So we will get negative 10 over 18, which is negative 0.55. So this would be a 55% decrease. And that's what I mean by you drop the negative, because the word decrease is telling you that it's going down, so you don't need the negative anymore. Now for this question, we were asked which one had a higher relative change in terms of magnitude, which just means that we forget about the sign. I don't care about if it's decrease or increase, I just care about the percent number. So since 55 is greater than 24.6, you wouldn't have to write that down, but just to really knock it home as to why it is what it is, Cortex's has the larger relative change. And I'll clarify in parentheses in magnitude. Questions, concerns on that? All right. Let's see. Ooh, everything's falling. All right, we've got one more of these, and then we might be able to write down the next set of definitions, but we might not get too far into that. So we got the puppy that Sam brought his girlfriend was originally priced at $980. Whew, that's a lot for a puppy. And he got it on sale for $650. Still a lot for a puppy. How much of a sale did Sam get? So the original price was $980, so it started at $980, ended at $650. So we have $650 minus $980, end minus beginning over beginning. I don't have this in my notes, so give me 2 seconds to calculate that. 650 minus 980, negative 330 over 980. Oh, my laptop's angry. One moment, please. Every once in a while, my laptop just drops the Wi-Fi for no good reason. It just hates me. There we go. So negative 330 divided by 980 will give us negative 0.3367. I'll take 4 decimal places because we're going to change it to a percent. So it was essentially a 33.67% decrease. So the sale was a very silly sale. It was 33.67% off. Imagine all the signs that I'm sure were plastered all over the store. Sale, 33.67% off puppies. Anyway. Questions, concerns on relative change, because that's the last question we have on relative change. If I'm quite honest, I don't use these types of questions a lot. Relative change. Average rate of change, totally, all the time. We'll ask you all the average rate of change questions. Relative change, I'll probably ask you 1 or 2 here or there, but it's not used as often as average rate of change in other contexts and other processes. So, just so you know. 5 minutes. Let's write down the next set of notes, at least, so that we can at least start off next time just jumping into things. So, the last thing we will talk about in this section is something called concavity. Now, if you've taken calculus before, you will know, hopefully, the word concavity. Usually it's not presented this early. So what happens in this class, and it's a little weird, these notes mainly follow Hughes-Hallett. So there is that online textbook, and it does talk about concavity as well. But Hughes-Hallett is kind of the reason this is here now. So we're going to kind of like introduce the idea of concavity, and then it's going to come back to us in later sections again, because it's actually more of a calculus concept, and we're not in the calculus yet. But anyway, so we have that the graph of a function is something called concave up if it curves upwards as we move from left to right. So you kind of have 2 options for that. You have something that looks like this, which kind of makes sense that that curves upwards, like as you're looking from left to right, it's going up faster and faster. It's kind of curving upwards. And then the one that might take a bit more time to get your head wrapped around is something that looks like this. This is technically also curving upward, and what you want to think of is technically, imagine you were like flying a drone, and this was like where the drone was, and say the drone was headed to the ground and you're trying to make it pull upwards. Well, if you want it to start going upwards, first it's got to stop going downwards, right? So if like the drone is going down and you're trying to you're pushing up on the little controller thing to try to make it go up, it's got to slowly come down to a stop before it'll start going back up again. Right? So that's why that's technically considered curving upwards, if that makes sense. Usually we'll group these 2 together. So like if I flip-flop the way I wrote those and shove them together, you get that. This is usually what I'll write when I need to refer back to concave up. And sometimes people say concave up like a cup, because that's cute. So concave up like a cup. And then the opposite way, we have concave down, which means that we're curving downward as we move from left to right. So the one that kind of makes sense is something that would look like this. Why is it writing over there? And then the one that takes a tiny bit more time to maybe wrap your head around is something that looks like this. But again, same idea if you're driving a drone and it's going up to the sky and it's about to leave the atmosphere, like that would happen. And you're trying to make it come back down to you, it's got to like slowly stop going up first before it'll start going down. So that's considered curving downwards. So again, we can kind of plop those 2 together and people will say concave down like a frown. So concave up like a cup and concave down like a frown. Those 2 kind of parabola pieces I will be drawing a lot especially when we get to concavity. Again, this one's a little, there we go, that looks nicer. Especially once we get to concavity in terms of the calculus material, I'll be drawing those a lot. A lot of times you'll also, maybe not necessarily because my video is really small, but I also like to put a little cup or a frown in front of my face when I'm talking about it. But anyway, no one is probably looking at my video, so no one will ever see me being a total dork and doing a bunch of concavity things with my hands. Anyway, a straight line is neither, can I read? Neither concave up nor concave down. So if it's a straight line, it doesn't have any concavity to it. It has to have some type of curve to be concave up or concave down. So on Wednesday, we will actually go through these two problems on concavity, but we're running out of time today. So really quickly in chat, I will write out what your quiz on Wednesday is going to look like. It's going to include things like finding linear equations, like our warm-up this morning, and then average rate of change questions. So that's written out in chat. I'll also put it up here in case my chat's lagging. So your quiz, finding linear equations, and average rate of change. Also, really quick before you go, technically my office hours today are supposed to be 1:30 to 3:30. I'm just created an important meeting that's probably going to run between 1:30 and 2. So I will be on there as soon as I get home. I should be on around 2 o'clock. Maybe a little later if I'm running a little late, but 2 to 3:30 today. Hopefully I don't have to make this change a lot. Otherwise, also, I can stick around here for a couple of minutes. I have a little bit of time before I have to leave. But if you have any questions that you know already and want to stick around to ask me them now, you can do that. But otherwise, my office hours are going to shift the tiniest bit today. Also, Peyton, SI session tonight. If anyone needs any help. Remember, also, because someone asked me, I don't know if it was this class or last class, SI is optional. Like, you don't have to go. It's suggested if you need help, but I had someone thinking that it was required and it's not. But if you need the help, especially your homework due tonight, 6 p.m. SI session with Peyton. All right, anyway, we're done. If you have any questions, again, feel free to stick around a little bit. Otherwise, have a great day, and I'll see you on Wednesday.